Hey everyone, welcome back to the channel. In this video, we're going to be continuing our DP-700 exam preparation course. This time, we're going to be going on a journey through fabric monitoring, identifying and resolving errors, and optimization. Now, this might be quite a long video because I'm going to try and go through all of it in one go. Now, don't worry, we're going to break it down into different parts. Now, all of these parts as a whole, they make up all of section 3 of the study guide for the DP-700 exam, but I've just completely reordered them all into an order that I think makes more sense. So in part 1, we'll be going through fabric-wide monitoring and optimization tools. So these are tools that you'll use across lots of different experiences, lots of different tools within Fabric. And I'm talking about the Monitoring Hub, I'm talking about the Capacity Metrics app, and I'm talking about the Workspace Monitoring feature, which is a new feature that they've just released. Probably won't be in the DP-700 exam, but I think it's going to be an important part of fabric monitoring going forward, so I wanted to cover it. In part 2, we'll be looking at monitoring, error handling, and optimization and alerting from this class of data processing tools, right? So in this category, we're talking about data flows, data pipelines, Spark notebooks, Spark job definitions, event streams, right? So anything that takes data from one place and puts it in another place or does any sort of processing or transformation, all of those sorts of tools, we're going to look at how you can monitor them. And we're going to get into detail about each one, right? Because each of these have slightly different ways that we can monitor them, different ways that we identify and resolve errors, and optimization as well. Then in part 3, we're going to be looking at the monitoring and optimization of some of the different data stores in Microsoft Fabric. So we're going to be looking at the data warehouse, how we can monitor queries and optimize them in the data warehouse itself. Then we're going to be looking at the Lakehouse and the Delta file format and how we can monitor and optimize all of those things. We'll be looking at the event house and how we can, again, monitor the queries that we're running in our event house. And we're going to be talking about KQL optimization inside your KQL databases. And then finally, we're going to be looking at semantic model refreshes, which is kind of a form of data stores. How do we monitor those? Just kind of like shoehorned in at the end there. So we're going to be going on a journey. Strap in. Let's go through it. Okay, so let's start with an overview of monitoring and errors and optimization in Fabric. Let's just set the scene here. So this section is going to be different from what we've looked at so far in this course, because most of what we've looked at so far talks about building new solutions, right? And as a data engineer, that is part of the job, building new tables, pipelines, things like that. But for a lot of data engineers, a large portion of their job, especially once you've built the thing in the first place, is around managing, maintaining existing solutions, right? Now, there's two broad categories of work that we do when we're managing and maintaining existing solutions in production. Now, one is when things go wrong, right? So what this looks like normally is there's some sort of monitoring process, hopefully, where you're identifying bugs and errors when they occur in production. So your pipeline fails, for example. If it gets really bad, then something on the front end, one of your visuals shows some sort of error for the user, or perhaps some sort of Spark job has failed, right? So we need to learn how to monitor all of these things, identify where the errors are, and then normally we need to resolve those errors, understand what's gone wrong, and then resolve them through, it depends what the error is, right? So updating your code, perhaps in some instances, building and then deploying the solution back into production. The other category of work that you do with solutions in production, well, it's not particularly fixing bugs and errors, but this time on the right-hand side, we're focusing on development of new features and optimizations. So things aren't broken necessarily, but you could do them better, right? So you might want to refactor some code. Again, there's this kind of loop here where you're monitoring a solution. This time you're monitoring for things like cost or speed or efficiency, right? Not necessarily for bugs. Once you've identified, maybe you've benchmarked against, what the solution or the cost efficiency a month ago versus it is today, for example, then you might want to identify chances for improvement. Again, that could be in the cost. Now, that could be in the number of capacity units that your pipeline is using every time it runs. You think, this is using a bit too much. There's an opportunity here to refactor my pipeline. And again, you're going to do some sort of improvement, build and deploy step. And again, it's kind of cyclical, right? You might go through stages in your development lifecycle where you are focusing on certain parts of your infrastructure that you want to optimize the performance of. So in Fabric, what does that look like? Or what tools do we have available to us at a Fabric-wide level? So this is the diagram here that I would use to represent monitoring at different levels in a Fabric environment. At the top here, we have the tenant level monitoring, which is Monitoring Hub. We'll have a look at all of these different things in a minute, but I'm just talking you through how these things all fit together. In the Monitoring Hub, you get access to everything that you have access to in Fabric on a personal user by user basis. Then you have the Capacity Metrics app, which is obviously at the capacity level. And in that, you get an overview of the capacity consumption for a specific Fabric capacity in your organization. Then at the workspace level, now we have workspace monitoring, and it looks a bit like this. You turn on workspace level monitoring and you get given this event house. And for certain Fabric item types, you get real-time monitoring. We'll look at this in a minute, but some of the supported item types are things like mirrored databases, semantic models, GraphQL queries. So it's not a full coverage of absolutely everything in Fabric yet, but it's useful to know about. And then we have what I would call item level monitoring, right? So each of these individual items, and more of them, run out of space in my diagram here, but each item has its own interfaces for getting more details about run details, historic runs, refresh updates. So when you're debugging or you're looking for optimizations and things like that, typically you'll be using all of these different levels, right? Normally always the monitoring hub as the kind of central place to go. If you're looking for things like cost efficiencies, then you'll be looking at the Capacity Metrics app. If you're using any of the tools that are supported by Workspace Monitoring, then you'll go there. And eventually you'll want to dig into the details of what's gone wrong or individual items runs. So you're going to be looking at these item details. So let's just talk about the Monitoring Hub, because the Monitoring Hub is a central place to track the status of both current and historic runs of Fabric items. And it's broken down by the item types. So here I've got a filter on just for notebooks. Might be a bit difficult to see that, but I'm showing you only just the notebooks here, but obviously you can remove that filter and it will show you absolutely everything. So here we're talking at the tenant level, okay? So you get access to all of the different Fabric items that you have access to, and you can see their monitoring status. The type of monitoring here, we're monitoring things like run statuses here. So has it succeeded? Has it failed? Is it still ongoing? That kind of thing. We're also looking for errors and failures, right? So this would be a great place to come to check what's failed in the last hour or so. Now, as well as just the high level summary of all the different runs in your tenant, you can also click into these and get the more detailed logs. Now, these vary depending on the item type, right? And we'll have a look at what these look like in a second. But just know that when you click on a particular activity name, like this one here, depending on the item type, it's going to take you through to a different interface, right? So it's going to take you through to the Spark monitoring tab, because these are Spark notebooks in this instance. Supported items are things like the data pipelines, the Dataflow Gen2, notebooks, Spark job definitions, semantic model refreshes also appear here. And as I mentioned, each of the items above has a different click-through experience, right? That's what I would call it. That's not the official word for it, but when you click on an individual run, you'll get a different view on things. Okay, so here we are in the Monitoring Hub. Now you can get to this page on the left-hand toolbar here. So wherever you are in Fabric, I can be clicking on anything in here, and either it will come up here on the left-hand side, like this one is showing for me. But if you can't see that, just click on these three dots. It's probably hidden. It'll be in this selection here. So if we click on Monitor, what do we get? Well, we can see in real time the pipelines and the semantic model refreshes and anything that you've got going on in your tenancy. So I can see the different activities, their status, the item types here as well, when they started, who they were submitted by, and the location, the workspace. I can filter on this list, say I only care about what's failed, and I can drill into any of these things that have failed. As I mentioned, each of these item types has a different click-through experience. So if I click on a particular activity, a particular run, like this one that's failed, it will bring me through into the data pipeline and we'll get this activity summary. So we can see each of the activities as they ran in this particular run of that data pipeline, we can see which individual activities failed. In this instance, the first activity succeeded, and then all of the rest, something in this for each loop has gone wrong. We can click into the individual error messages, and we can see that for this one, there was some sort of connection issue, right? So maybe I've moved one of the databases, or something's changed in the connection details. So you can go into this for each loop and you can debug it in more detail, right? You can click through to update the pipeline here if you need to, which I will need to probably in this case. It's not a transient error, likely. It's probably something that I need to actually change in the configuration of this for each activity. If we go back to the monitoring hub, let me find something a bit different. So if I click on the semantic model in the monitoring hub, here we get a slightly different UI that's going to show you all of the different details for this particular semantic model refresh. Again, we can click on it and see why that particular one failed, something to do with the gateway, data connection, so we can then go and debug that. One thing to point out here with this table down here is that we can add quite a few more columns here. So if you want to know end time, duration, which capacity it was running on, which is useful. Other things like the average duration, so that you can monitor the current duration versus the average duration, that kind of thing. All of these are quite useful things that you might want to add into this table down here. Now, currently this data set is not really accessible. There was talk that they were going to open up this data set so that we can use that more flexibly in things like visualizations. I don't believe that's available yet, but it might be coming in the future. Okay, so next up, I want to talk about the Capacity Metrics app. So the Capacity Metrics app is a Power BI semantic model and report in a Power BI app. So you can download and install this in your Fabric environment, and then you connect it up to a particular Fabric capacity that you have access to in this bit up the top left-hand corner. Again, we'll do a bit of a walkthrough in a moment. And what it's going to do, it's going to show you the capacity consumption for all Fabric items in your capacity. Now, by default, the semantic model for this Capacity Metrics app updates once per day at midnight, but you can manually refresh it, and you can also refresh it with things like Semantic Link and data pipeline semantic model refresh activity as well. And you can build your own reports. So if you don't like this report, you can access the underlying semantic model and create your own report on top of it. So it shows you data at the capacity level, right? This is the Capacity Metrics app, but you do have access to workspace details down here, right? So you can fold up your analysis into different workspace, right? At the workspace level, which is useful, right? To identify which workspaces are consuming more capacity than others. Now, supported items, like what can we actually monitor through the Capacity Metrics app? Well, it's pretty much everything that consumes your capacity, which is pretty much everything. So let's go and take a look at the Capacity Metrics app in a bit more detail and highlight some of the key features. Okay, so once you've installed the Capacity Metrics app, it's going to create you a brand new workspace. This is my workspace here, and you can see that it refreshes. This is the date that I have been recording this video, the 19th of the 3rd, 2025. And so it regularly updates at midnight every night by default. But if you need more up-to-date data, then you can just manually trigger a refresh of the semantic model like this. Equally, as I mentioned, you can do things like create a report from the semantic model if you're not happy with the existing report. But there is a lot of work that has gone into that report, and they are constantly updating it. Okay, so here we are in the Fabric Capacity Metrics app. And the first thing to note is that we've got two pages here. We've got compute and storage. And this makes sense because this is the two ways in which you get billed by Microsoft in Fabric. Firstly, for the compute that you use, the SKU, and secondly, for the storage in OneLake that you consume. Now, the first time that you log into this app, you'll need to declare your capacity, and then it will take a few minutes and it will go and collect all the data for that capacity, and then it will present you with this table. Now, for the purposes of the DP-700 exam, you don't need a really thorough idea of absolutely everything that's involved in this dashboard, but just know, roughly what's included here, and let's just go on a very quick tour. So probably the most important part of this dashboard, or the place that I spend most of my time looking, is the top right. This is the CU percentage over time as a percentage of the total amount that I'm allowed to use for the given capacity I'm on. I'm using the trial, so this is an F64 capacity. So you can see that I'm drastically underutilizing my F64 capacity. I think it gets up to probably about 10% maximum currently. It's important to understand the terms like throttling and overages and system events for the DP-700 exam. So if you go over and above 100% for, I think it's more than 10 minutes, then you're going to start to experience throttling. It's going to start by rejecting interactive jobs, so users clicking on things in the interface of Microsoft Fabric. It's going to prevent people from doing that, which is not a good user experience. Then if you keep on going over 100%, then they will start to reject your background jobs, so your scheduled jobs like pipelines and semantic model refreshes and things like that. This tab is also quite important to understand, overages and burn down. So I'm not going to have much data here because I haven't throttled my capacity. But after a throttling event, which is one of the system events, is going to take that amount that you've gone over your 100% capacity, and it's going to steal from some of your future capacity allowance. It's going to make you pay back. So if that was happening to my capacity, that's what will get visualized here. Probably a better place to go would be the documentation, because they explain all of these concepts. And obviously in the exam, you have access to this, right? So you can understand the compute page here, and it talks you through each of these charts with an actual example of throttling. So this is what throttling looks like in your capacity, like here going above 100%. And for the overages as well, it shows you this burn down chart like so. So just know that you can access this during the exam if you need it. All right, I just want to spend a little bit of time talking about workspace level monitoring, which is a new preview feature. So you probably won't get asked about it in the DP-700 exam, but I think it's useful just to be aware of it because I think it will play a bigger part in Fabric in the future. So currently in your workspace settings, you can now enable workspace level monitoring. What that's going to do is going to create you this monitoring event house for your workspace, and it's then going to write logs into that event house in real time. The supported item types are currently GraphQL, operations, the event house itself. So if you want to monitor the event house in Fabric, you have to create another event house, this workspace level monitoring event house. You can also monitor mirrored databases and semantic models in here. And that's reflected in these different log tables. These are KQL tables that get created in this monitoring database, and data gets streamed into them. Log files get streamed into them. These top ones are to do with the event house. So any KQL logs that you've got there. Then there's things like the GraphQL ones, the mirrored database ones, raw logs, semantic model logs here. So this is in general what this looks like. I'm not going to go through, a demo of this because again, I don't think it will be in the exam, but it's useful to know about. And hopefully they expand the list of supported item types in here. Now, one thing to bear in mind that you do actually have to pay extra for this event house. So it's not a free feature. It's going to cost you money if you want to be monitoring these things, which for the event house is actually quite a difference compared to the other data stores in Fabric, at least from my understanding of how the billing works. Obviously, the data warehouse, as we're about to see in a future section of this video, has its own monitoring features built into the data warehouse. You don't need a separate data warehouse to monitor your data warehouse. Similarly with Spark monitoring, it's kind of built into that data store. But with the event house, you have to pay extra. Okay, so that was part one, where we looked at some of the Fabric-wide monitoring tools. In part two, I want to get into specific, what I would call data processing tools. So we're going to look at the data pipeline, the Dataflow Gen2, Spark notebooks and Spark job definitions, and the event stream. And for each of those, we're going to look at monitoring, error handling, optimization. So let's start with the data pipeline. So for all of these, really, the monitoring starts in the monitoring hub. That's probably going to be the central place that you go to look for things like failed pipelines. And then from here, you can click into specific pipelines that you want to investigate further. When you click on a particular data pipeline run that you want to investigate, then you're going to get this interface here. And we had a quick look at this briefly earlier on in the video. You can see which particular activities failed, and then you can investigate why, and then you can update your pipeline, or you can rerun it if it's just a transient error. Then within the pipeline kind of debugging interface itself, another useful tool is these inputs and outputs. Now, there's many different reasons why data pipelines can fail. Sometimes, as we saw, it was a connection issue. But if it's a failure with the data, which sometimes it can be, so maybe the structure of the data that you get back from an API, perhaps, changes, then what we can do is use these input and output sections to look at the specific data structure that's getting passed between your activities, because you're going to have to make assumptions about the data structure in your dynamic expressions normally. So when you're writing things like item.workspace ID, for example, and then that data structure changes, you're going to be using the inputs and the outputs here to see why that might have changed. Now, this is not just for debugging on production pipelines. So it's also useful when you're developing new pipelines as well, to understand what's getting passed between each of these activities. Okay, so that's how you would identify an issue and then potentially fix it in data pipelines. But what can we do during the design and the build phase to make our pipelines more resilient? Well, the first tool that we have is the retry setting. Okay, now this appears in a few different activity types: the copy data activity and the notebook activity, 2 examples. What this is going to do is it's going to try to execute the activity. Then if it fails and you specify this retry parameter here, it's going to retry that activity again. You can also specify a retry interval. So in this instance, it's going to try it. If it fails, it's going to wait 30 seconds. Then it's going to try it again. Why is this useful? Well, if you have some sort of copy data activity, for example, that connects to an external system or an API, then sometimes it's useful just to give it another go, right? Because you can get things like transient errors. It might not work the first time, might be some sort of network issue, but it's temperamental. It only lasts for a second or so. Just so happens that when you were making your request, it was down, like the server that you were connecting to or whatever. So if we can retry and get a successful connection the second time, that's going to make your pipelines a little bit more resilient. It's going to prevent you from getting a completely failed pipeline that you have to go and debug and spend a lot more time looking into. So that's a useful thing to know. As well as that, on the copy data activity specifically, there are these settings here, right? So you'd be used to defining the source and the destination and the mapping for a copy data activity. But on the settings tab, there's a few other interesting settings to be aware of. The first one is intelligent throughput optimization. Now, this is a number between 4 and 256 of how much CPU should be assigned to this copy data task, right? Does it require a lot of compute or not much? Obviously, if you specify a higher level of compute, it should get that job done quicker, but it's going to cost you more capacity consumption. Another thing we can do to optimize these copy data activities is adjust the degree of copy parallelism, right? Now, the default for this is 128. So they're already using a lot of parallelism when you use a copy data activity, but it's something to bear in mind and to play around with. You perhaps might be able to increase this and get a better performance, but it does vary on the dataset and also the source as well. Next up, we have fault tolerance here. Now, this is a drop down and it's going to give you a few options that you can select. Now, some of them are related to tabular data that you might be bringing in, and some of them are for file data. So in this example, I'm bringing in tabular data. So these ones are grayed out, so I can't edit these ones. Essentially, what fault tolerance gives you is it gives you the ability to skip rows and files where it finds problems. So if you've got a CSV file and it can pass 99 rows out of 100 rows in that CSV file, what it's going to do is it's going to skip the rows that it cannot pass that are incompatible, but it's going to carry on with the copy data activity for the compatible rows. Similarly, for files, if you've got a ADLS Gen2 storage account and it's got 50 files and you're bringing all of those in, if you have this fault tolerance ticked for skip files with invalid names, for example, perhaps some of them are not named correctly, then it's not going to break your pipeline. It's just going to ignore them. Now, you do need to be careful with this because make sure that you are logging those skips, because otherwise you don't want to just forget about those files. So fault tolerance is good in some instances. Sometimes we want to actually know when there's a problem so that we can go and address it. Next up, we have logging. So we can write detailed log files to an Azure Blob storage account if we tick this. And then there's staging, right? So we can use either one of the workspace staging data stores that you have already in your workspace, or you can use an external environment like a blob storage as well as your staging environment for bringing this data in. Next up, it's important to understand that if things do go wrong, we looked at these dependencies on the end of a data pipeline activity here. We have on success and on fail. On the on fail, we can set up notifications. So there's a few different types of notifications that we can send. Office 365 and Teams are the main ones. You can also connect to any sort of other API, right? So you can connect to a Slack API, for example. But in terms of out-the-box activities and notifications, you have Office 365 and Teams. One thing to note is that in the parent-child architecture, you can capture all of the failures from what happens in your parent pipeline, right? Rather than, what you sometimes see is this kind of thing, notification coming off if there was another activity here, lots of notifications for every activity, which is not very efficient and it's not very good pipeline design. Instead, what you can do is wrap this up, make this a child pipeline, and then call it from your parent pipeline, and then deal with notifications from the parent. Now, as well as the out-the-box monitoring solutions, obviously this is a Microsoft Fabric exam, so the focus is going to be on the out-the-box monitoring solutions, but you're well within your right to build custom logging solutions if you've got more unique requirements, or you want to log different stuff to what you get out the box or at different intervals, for example, then you can always build your own logging solution. Very simply, you can use a script activity. Perhaps you want to write to a Fabric SQL database. That can be your logging engine that you want to write to, or you can write to a KQL database directly from your data pipeline is another way to go. All right, next up, let's talk about the Dataflow Gen2. So for Dataflow Gen2, there's a few different ways where you might notice there is a problem initially, right? Maybe one of your data flows has failed and you schedule your data flows within the actual data flow itself. Then you might see this sort of icon appearing next to the refresh date here. This means that you've got a problem and the last refresh has not been successful. Normally, what you can do is you can right click on your Dataflow Gen2 and go to the refresh history, and you get all of the details about the different refreshes for that particular Dataflow Gen2. And again, you can click on individual refreshes and diagnose exactly what went wrong for that refresh. That will take you through to a screen like this. You can see exactly which of the tables, if you're doing more than one tables, were successfully loaded, which activities failed. And in this example, the write to data destination for the titles table failed, right? And we can see why that is down here. Issue with the mashup document, cannot update the table. The type of column, end year, doesn't match the type of column in the table. So there's something going wrong with the mapping of data types in this example. So there's a few different optimization strategies that you can use within the Dataflow Gen2. So if you're experiencing high capacity consumption, which let's face it, you might be using the Dataflow Gen2 because it is the highest consumer of capacity units of all of the data processing tools, there are some optimization strategies and tools that are available to you to try if you're using too many capacity units with your Dataflow Gen2. The first thing to try is fast copy. So depending on the source of your Dataflow Gen2, where you're getting the data from, you can enable fast copy. You have to enable it from the settings of your Dataflow Gen2 first, and then you can right click on the query and click on enable fast copy. Essentially what that's going to do is it's going to bring the data in using the infrastructure of the data pipeline copy data activity. So you're going to get similar performance to what you get from a data pipeline rather than the data flow. The other optimization strategy or tool or technique to be aware of is staging. So if you enable staging, what's going to happen is your data flow is going to extract your data from the source. Then it's going to write that data directly into a staging warehouse or lakehouse. And then it's going to use that staging environment to perform any transformations. And then it's going to return it back to the data flow for it to get written into the final destination. Now, on large data sets or data flows where you've got a lot of transformation going on, this might improve the speed of your data flow. For small data flows, small data, not doing many transformations, it's likely to add more overhead than it's going to save. All of this writing and reading from different data stores adds a little bit of overhead, which on smaller data sets and small transformations, not really worth it. In fact, it will end up costing you more, taking you more time than if you turned off staging. There's also sort of best practices here around converting, if you've got very complex data flows where you're trying to do many different tables in one data flow, then it's best to separate these into separate data flows, right? One query per data flow if you can, and then just orchestrate them as separate data flows. If you've tried some of the optimization techniques here and you're still not getting good enough performance, then what you can do is try something else. So the Dataflow Gen1 consumes less capacity units. The copper job consumes a lot less capacity units. Now, these are just anecdotal, let's say, performance benchmarks, but in the future, I'll be doing a lot more analysis of the capacity consumption of all these different things, but this is just from what I've read and experimented with myself briefly. Then I would argue, the notebook or the data pipeline is always going to be a better choice. If you have those skills available to you in your organization, I'd recommend using data pipeline or a notebook or both. All right, so let's talk about the Spark notebook and Spark job definition and how we can monitor and optimize these tools. So in Fabric, there's 3 main tools for monitoring Spark. The first one is going to be the monitoring hub. Within the monitoring hub, we can click on either notebooks or Spark job definitions, and we can get high-level information about whether those notebooks or Spark job definitions have passed, failed, still ongoing, that kind of thing. Then we can click into each individual run here to get more detailed information. So here we are in the monitoring hub, and I've set a filter here just for notebooks, just so that we can investigate what this looks like, the experience of clicking through and understanding what happened in this particular notebook run in more detail. So say I want to investigate this one here, this notebook that's run. When we click through, the click-through experience looks different to everything else in Fabric. We have the list of the jobs that were running in this notebook during that session. We also have links through to a monitor run series and the Spark history server. So let's go and look at those and explore what these are in a bit more detail. And as we're looking through them, just take a note of what exists in each of these tools, so that in the exam, if you get a question about, where would you go to find X or where would you go to find Y, then you know the answer when it comes up, depending on what the question is. All right, so let's step into the monitor run series. So in essence, the monitor run series captures data about how your specific Spark jobs are running over time. Now, this is perhaps not the best example because there's only 2 Spark runs here over time. But in theory, you would get a nice graph here of how the duration and the number of bytes that you're reading and writing in your Spark job or notebook changing over time. So if you've got this on a schedule every hour, every day, then you get a nice chart here of how this thing is performing over time. There's other more detailed information in this monitor run series around, to what extent how the executors were functioning, what they were doing throughout the different parts of this particular Spark job or this notebook. Was it read heavy, write heavy, doing shuffle read, shuffle writes? Is it CPU or CPU overheads? It also has this anomalies feature where it's going to highlight any sort of anomalies here. Again, there's probably not enough data for it to show any anomalies, but if something out the ordinary happened on one particular run, it would highlight that and flag it in these anomalies section. If we go back, next up, I'm going to look at the Spark history server. So of course, if you're using Spark, you get access to the Spark history server. So this is not really a Microsoft Fabric feature itself, but it's a feature of Spark. You get this web UI and you can click through this particular run. Again, we get important things like the event timeline here. So it's going to show you, all of your different jobs, succeeded, failed, running in a kind of nice timeline. If we scroll down, we can look at, each job individually here. We've also got access to things like the graph for this kind of query plan view and a look at diagnostics as well, if we want to analyze things like skew, so data skew and time skew. So there's quite a lot of options available when you're monitoring Spark notebooks and Spark job definitions. Let's head back to the slides. Okay, so let's just summarize what we saw there. For Spark notebooks and Spark job definitions, you have the monitoring hub, which is going to be the first place you go, probably. Then you can click in and you can view things like the monitor run series UI. It's going to allow you to get statistics about the performance of your Spark jobs over time. Then you've got the Spark history server. If you want to go on a deeper dive, you want the event timeline, you want detailed logs and query plans for your Spark jobs. That's where you would go. Next, let's talk about the event stream. So the event stream has a few different monitoring aspects available. Number one is data insights. So inside an event stream, you'll see this tab down the bottom called data insights, and it's going to tell you 4 different metrics. You've got the incoming messages, like the number of messages it's ingesting, the outgoing messages, so the number of messages that are flowing into some sort of destination over the specified period, the number of incoming bytes and outgoing bytes. So you can get a high level understanding of the number of messages and the number of bytes that are passing through this event stream in the last hour. We can obviously update that to, a different time scale as well as data insights in the event stream. We also have runtime logs. So these are created by the event stream engine, and a log is created normally when anything goes wrong, right? So you might have a warning, an error, or some sort of information. So these would be the 3 different levels of the runtime logs. In this example, I've got this failure happening in the last 24 hours. There's 200 of these. So there's some sort of output failure in this event stream that I would need to address. And to do that, I would go to these runtime logs. All right, so let's move into part 3, which is monitoring and optimization of data stores in Microsoft Fabric. Let's start off with the data warehouse. So for the data warehouse, there's 2 broad groups of monitoring tools. There's what I would call the UI-based tools. For those, we obviously have the capacity metrics app, and we have the query activity tab in the warehouse. Now, the second group of monitoring tools is the query-based monitoring. So if you want to be writing T-SQL to analyze your monitoring data, your logs, then you have the query insights schema, plus some dynamic management views that you can also access. So we're going to have a look at all of those monitoring tools, and then we're going to look at how we can optimize our code and our Delta tables inside a data warehouse using V-ordering, so turning off V-ordering because it's by default on for the data warehouse. Okay, so I just wanted to start off with a quick chat about the capacity consumption. So if your query or what you're trying to investigate in your data warehouse is to do with the capacity consumption, how much capacity is being used in a particular data warehouse, or investigating spikes in capacity consumption for particular queries, then you're going to want to go into the capacity metrics app. Obviously, you can filter by particular item types here. So I filtered by the warehouse here. Then I've got a list of all my warehouses here, and I can see the capacity usage for each of these. Now, if we move into the data warehouse itself, recently Microsoft have launched the query activity tab, which looks a little bit like this. Now, the query activity section is broken down into 3 subsections here. So you've got query runs, long running queries, and frequently run queries. And together, you can use these to diagnose different queries that are being run in your data warehouse. Starting off with the first one, query runs. This is useful because we can use it to cancel long-running jobs. So if you've got a SQL job that's been running for ages and ages and ages, and there's some sort of issue with it, it's not going to come to a satisfactory completion, you can just cancel it. Then you have this table down here, and this table is essentially a long list of all the queries that have been or are being run against this data warehouse. You can see the query text, you can see the duration here, the timestamp, who executed that query, and the session ID for that query. Next up, in the long running queries tab, now this is an aggregated view on the query runs. So for each query text, it's basically going to do a group by, and it's going to show you the medium run duration here, which is what this table is sorted by, the run count, the last run duration. So this is really useful for identifying which queries are a long running, right? And they might be candidates for optimization, refactoring, that sort of thing. You've also got frequently run queries, this third tab here. Now, similarly to long running queries, this is another group by or another summarization of the query texts. This time it's sorted by the run count here, this column. So how many times has this query text been executed on this data warehouse? Now, obviously, both of these are candidates for optimization. You want to know which queries are the most frequent and which are long running. Now, if you don't want to be using that nice user-friendly UI to perform your analysis of those logs of your previous runs. We also have access to this query insights schema, which has 4 different views in it: exec requests and exec sessions histories, the frequency run queries, and the long running queries here, which essentially surfaces the same data, but it's accessible via T-SQL. The next thing I want to talk about around monitoring and optimization of tables in a data warehouse is V-ordering. So V-ordering is a proprietary algorithm that Microsoft owns that essentially changes how Parquet files are written. It optimizes them so that you can read them very quickly through things like Direct Lake. So it takes longer to write because it performs, this optimized write, and it takes a bit longer to write, but it's a lot quicker when it goes to read it. Okay. Now you can turn it off, this V-ordering. It's on by default. You can disable it at the warehouse level only for the data warehouse, so not for individual tables. And very importantly, this action is irreversible. So if you turn V-ordering off for the entire data warehouse, then you can't turn it back on. This is how you do it. Alter database current set V-order equals off. Why might you want to do this? Well, if you're implementing some sort of layered architecture, maybe you have a raw warehouse, a staging warehouse, and an analytics warehouse, or if you're using a medallion architecture, bronze warehouse, silver warehouse, gold warehouse. Well, if you think about it, which layers in your architecture do you want to be optimizing for write speed, and which do you want to be optimizing for reading speed? Well, essentially, the gold layer or the analytics layer, the one that you're going to be building your semantic models on top of, you're definitely going to be wanting to have V-order equals on in those data warehouses. It's less important, in fact, it might be more optimal to turn it off in, for example, a raw data warehouse. You're just writing lots of new data into it, but you don't have really analysis being done on top of that data. There's not many reads of this raw warehouse. So the Parquet files don't really have to be optimal for reading. It's better to have a quick write time in these environments. So that is where it might make sense. Let's talk about Lakehouse and Delta optimizations now. Previously, we've discussed Spark monitoring via the monitoring hub, monitor run series, and the Spark history server here. Now let's have a look at the table maintenance features available to us within the Lakehouse for optimizing our Delta files. Then we're going to move into code-based optimizations, so performing similar stuff like optimize, V-ordering, vacuuming, but via code-based optimizations this time, rather than, these table maintenance features are UI-based, ad hoc maintenance features. And we're going to look a little bit at partitioning as well. So table maintenance is a relatively new feature, and it gives us the ability to manually manage, maintain, and optimize Lakehouse Delta tables. In the Lakehouse, uniquely, we have quite a level of control and visibility over the underlying Delta tables, right? We don't really get that in the data warehouse. There's not much we can do to optimize the Delta other than that V-ordering that we looked at. But, there's a lot more fine-grained controls within the Lakehouse. How do we do this? Well, we can right-click on any table in our Lakehouse and click on Maintenance. Then you're going to get this pop-up come show up, and we get these sorts of settings. So we can choose to run an optimize command, apply V-order, and run vacuum commands. So let's just talk about what each of those does. So optimize is a compaction algorithm or process. It's going to consolidate smaller Parquet files into more optimally sized Parquet files, right? So because we're using primarily the Spark engine for reading Lakehouse Delta tables, there is an optimal size for the Parquet files in our underlying Delta tables. So what Optimize does is it takes all of your existing Delta and underlying Parquet files, and if it sees a way to optimize and reconsolidate the structure of those Parquet files, it will do so. Then you can optionally apply V-ordering on top of that. So after you've done the consolidation, you can also add in that V-ordering. V-ordering, of course, is the write time optimization that's going to allow super fast reads from things like Direct Lake. The final option here is vacuuming. Vacuuming essentially is going to remove any unreferenced Parquet files. So the way that Delta works, as hopefully you're aware of by now, if you're frequently updating a Delta table, you're going to get lots and lots of Parquet files, and it's managed by that JSON log file. It's going to tell you which of the underlying Parquet files are part of the current version of that Delta table. Over time, this can lead to a lot of unused and unreferenced Parquet files from previous versions of the Delta table. Now, normally you want to keep some history of these unreferenced Parquet files if you want to allow your users to do things like Delta time travel over the last 7 days up to 30 days. We can change the number of days, what's called the retention threshold here. Here it's 7 days, but we can update that to a maximum of 30 days. What that's going to do, if we run this vacuum with a retention threshold of 7 days, any unreferenced Parquet files that are older than 7 days, it's going to remove them from that Delta table. This is going to free up space, but it's going to prevent you from performing Delta time travel on that table going back more than 7 days in the past. So that's the new UI-based optimization. The problem with that is that it's ad hoc and kind of like click and perform, which is useful, but you might want to automate these table maintenance features, put them in a notebook, run them on a schedule, depending on your table maintenance strategy. So let's just look at those optimizations in the code now, and I'll show you the Spark SQL implementations here. Optimize my table. Here we're also adding the V-order, so it's going to perform the V-ordering after the optimize. And for the vacuum, very simple, just vacuum my Delta table. Now, V-ordering in a lakehouse is a little bit more complex, or there's more options available to us. We can enable or disable V-ordering in a lakehouse at various different levels. Now, these are the default values for 3 different levels of V-order settings, right? The first one is session level, then we have table level, and then we have at the data frame writer level. So essentially at the cell level. So individual cells in your notebook can write in different configurations. So what does this mean? Well, at the session level, any data frame .write commands that you issue, by default, they will use V-ordering, right? At the table level, we can change the default V-ordering for a particular table. Now we can do that during table creation, or we can alter existing tables. The property we need is delta.parquet.vorder.enabled. The default value for this is false. So if we want to change that to true, we can do for individual tables. But just remember that the session default is true. So that's going to overwrite this. Finally, if we want even finer grained control over our V-ordering, we can do it at the data frame writer level. Let me just show you the examples that will make that a little bit clearer. So for the current session, we can set it to off like so. For individual tables, we can do create table using Parquet with these table properties like so. And for individual cells in a session where V-order is off, we can add in this option for Parquet.vorder.default is true. Similarly to how we talked about with the data warehouse medallion V-order optimization, the same thing applies, or the same scenarios of when we might want to enable V-ordering applies equally here. Essentially, if you want to optimize your table for reading, like these ones here in the gold layer, then you want to be turning your V-ordering on. If you want to be optimizing for write speeds, then you want to be turning your V-ordering off. Now, it's a little bit outside the scope of the DP-700, but there's a really good blog article by Santosh here around optimizing Spark Compute for medallion architectures in Microsoft Fabric. Definitely recommend. It goes into a lot more detail about the different tunings that you can perform at different layers in a medallion architecture to optimize performance. Next up, I just wanted a quick word on partitioning. So partitioning, because Spark is a distributed processing engine, partitioning can help with performance. If you've got incredibly large Parquet files that are terabytes large, for example, that is going to be difficult to send through this distributed processing engine. So partitioning is a method that we can use to break up very large files into smaller files so that we can take advantage of Spark's distributed nature. It's pretty simple. We can add into our write statements partition by, and we can add in partition column or columns. Just be careful to note some best practices here. You don't really want to be implementing partitioning until you're struggling with performance and you've got very large data sets. So you don't want to be trying to partition small data sets because that's going to not help your performance. It's going to hinder your performance. You got this problem called the small file problem. So don't over optimize too early. Your partition column, in a kind of similar vein, your partition columns, the things you choose here, is very important. Okay, so how are you likely to be querying that data downstream is important. And what's going to be the size of your partitions when you partition by these different columns? Are they likely to be equal, or are they going to be badly distributed? A good rule of thumb is to aim for 1 gigabyte partitions, right? That's what the best practice on the Delta Lake documentation mentions. All right, we're making good progress. Let's dig into the Eventhouse and KQL optimizations next. So again, the capacity metrics app is where you're going to be wanting to go to monitor capacity usage from things like your event streams, your Eventhouse, KQL database, and all of that good stuff. Now, the real-time intelligence experience in general is a heavy user of capacity units. So if you're implementing a real-time solution, you're going to be wanting to get quite familiar with the capacity metrics app and looking for ways which you can optimize your spend. You also have the monitoring Eventhouse, which we mentioned briefly at the beginning of this video, to go into a bit more detail about what that contains for the Eventhouse, where you'll get the command logs, which is a list of all the commands that are run on your KQL database, data operation logs, so a list of all the data operations, ingestion results, all of the results of your ingestions, the metrics, so details about ingestions, materialized views, continuous exports, and query logs. Potentially the most interesting or useful for you if you're managing an Eventhouse. All the different queries are getting run against your KQL database are stored here. So let's talk a little bit about query optimization of KQL. Now, like many query languages, the order in which you perform your operations matters a lot. And this is especially true with KQL. When we were looking at KQL, we talked about how you've got the table and then you've got different operators on different lines, and the data passes from one line to the next line. So the order in which you perform these operators or these activities matters a lot. The golden rule is to try and remove columns and rows as early as possible in your queries. Let's take an example. Here we've got sensor readings, which is one data set, and sensor metadata. Now, sensor reading has way more data in it. It's an IoT sensor data, and the sensor metadata is just data about each sensor. Let's say we wanted to join these two data sets like so, and then we wanted to perform a where statement. So we want to filter the output for just, a few different sensors, like between this range here. Now, the problem is that when you do this, it's going to perform your join first of both of these data sets, right? And that's going to be a very big join on at least one very big data set. So it's going to have to perform all of these different joins against the whole data set like so. And then the next step, this where statement, you're going to filter out most of it anyway. So all of this has been wasted effort. Instead, what you can do is refactor that. And ideally, you want to be pushing your where statements in a KQL statement as high up as possible to narrow down, the compute that's required. So in this example, we're doing a where and a project. So we're removing the data that we don't need here early on, and we're projecting, so getting rid of some data column-wise as well. And then we're just going to join that data set with our metadata. We're just going to return just the data that we need, and it's less computationally expensive. Here's another example of very similar stuff, but it's not just, range-based filters. Because KQL is a time series database, and most of the time we're streaming in things with a timestamp, you might just want to narrow down your query based on time, right? So I only care about the events happening in the last 24 hours, for example, and then passing that into your join. So I don't want to join the whole database, but only the most recent records, because I want to perform some sort of analysis on what happened recently, some event happened recently. There's other KQL optimizations. What I recommend is you go to the KQL documentation page. There's a list of best practices. We talked about the difference between has and contains, which is just one example of some other optimizations and refactoring that you can perform in your queries. Has performs an exact term match. So in KQL, it basically spits up strings into terms, and those terms are what's indexed. So that's going to be a lot quicker because it's going to do an exact term match. So if this title here was my whole string, a term would be this, like so. These would be my different terms. And so if I was to search for KQL, then it would return from a has operator. But if I was to search for KQ, it wouldn't return from the has operator, but it would return from the contains, because that also searches for substrings, right? And that makes it a lot slower because it has to search through all the different combinations of substrings, not just the terms. And the substrings obviously are not indexed, which makes it a lot slower. Also, the point we made around case sensitivity, if you have the option and you know the exact case of what you're searching for, that's always going to improve your query performance. So _CS is for case sensitive search. So you should always use that over has, which is insensitive. We've also got the case insensitive inequality operators, these ones here, that should also be avoided. All right, let's wrap off this video by talking about monitoring of semantic model refreshes. So previously in this series, we looked at triggering semantic model refreshes, and we talked about 4 different options available to you here. Now, the monitoring of semantic model refreshes depends on how you trigger it. Now, the traditional way, if you just set up your semantic model on a schedule, or at least one of the places you can look, is the good old monitoring hub. We can click on individual runs, we can see how they're getting on, and we can see how long it took and the status. And we can dig into that in a bit more detail if it fails, to have a look at the reason why it failed. If we trigger our semantic model refresh using semantic link, for example, using this sort of code here, using the fabric.refresh dataset method here, then we can use fabric.list refresh requests. We can use that to identify the different refresh runs for that particular semantic model, right? It's going to return a data frame that looks a bit like this, not just the ones that you've executed from semantic link, but all of them, right? It's going to tell you the type of refresh and the status, so completed or not. So we made it to the end of the study guide. That was a whistle-stop tour through the DP-700 exam. I hope you found that useful. In our next video, we're going to be looking at exam technique, tips, and tricks. If you haven't already, I recommend you sign up to our DP-700 bootcamp. We finished all of the study notes so you can get them straight away as soon as you joined up. We've also got probably about 10 hours of extra content for DP-700 that is not on YouTube. Plus we have access to 60 hands-on tutorials specifically for practice for the DP-700. So hope to see you there. If not, join us in the last video in this series where we're going to be looking at exam tips and tricks for the DP-700. I reckon you can gain 10% by implementing good exam techniques, so I hope to see you in that video.